Hi, ladies and gentlemen. We are looking at notes 1.2, which is on what function notation is. So if you notice right here, here's an example of what function notation is, and we're going to talk about this in a minute. But before we do that, let's do a quick reminder right here of what a function is. So remember, a function is a clearly defined rule that converts an input into at most one output. So remember, each input is only allowed to have one output. These rules often come in the form of, it could be an equation, in a graph, in a table, or in a verbal description. Okay? So let's take a look at exercise 1. Consider the function rule. So we're going to multiply the input by 2, and then we're going to subtract 1 to get the output. So let's go ahead and do this right here. In this example, 0 is our input. So when I multiply my input of 0 by 2, I get 0, and then I subtract 1. So I'm going to do 2 times 0 minus 1. So I end up getting 0 minus 1, which is negative 1. So that's my output. So it's kind of like a machine, like we talked about in class. You're inputting something, and then the machine is outputting the answer. Okay? Right here, the next input is 1. So I'm going to multiply the input by 2. So 2 times 1, basically, and then I'm going to subtract 1. So I get 2 minus 1, which is 1. So my output would be 1. Here, multiply the input, which is 2, by 2, subtract 1, and I get 4 minus 1, which is 3. Okay? And then lastly, I'm going to multiply this input of 3 by 2, subtract 1, so I end up getting 6 minus 1, which is 5. Okay? So then the next part says to write an equation that gives this rule in symbolic form. So it's saying multiply the input, and remember your inputs are always your x values. So I'm going to multiply my input by 2, and then, so I'm going to get 2x, and then I'm going to subtract 1, and that's going to get, so that's going to be equal to the output, which again, remember we said outputs are y's. Okay, so that's how you write your equation. Or you could just say y equals 2x minus 1. Okay, so now part C says graph the function rule on the graph paper shown below. Use your table in A to help. Or you could also use your equation in B to help, because this is the equation of a line. You know your slope is 2 and your y-intercept is negative 1. Okay, now it's really important that we go ahead and we label our axes first so we know exactly what the scale is. We've got x right here and we've got y right here, so we don't have to label that, but if it's not there, you need to make sure you do that. Okay, so 0, I'm just going to go by 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm at 10 here. 1, 2, 3, 4, 5 up here, and then 1, 2, 3, 4, 5 here is negative 5. Okay, so if I want to graph this out, I know that 0, the input of 0 has an output of negative 1. The input of 1 has an output of 1 right here. The input of 2 has an output of 3. And the input of 3 has an output of 5. Okay, and that's the pattern. It's going to keep going like this. So this would be my graph right here. So this is y equals 2x minus 1. Or I could just say my y-intercept is negative 1, and then I would go up 2 and over 1 because that's my slope. Okay? All right, so that's exercise 1. Now exercise 2 says in the function rule from number 1, what would be needed to produce an output of 17? So this time I'm telling you what the output is. And why is it harder to find an input when you have an output than finding an output when you have an input? So this time I'm not going to put my input into my function machine and it's going to spit out the output. I need my equation first. So I know my equation is y equals 2x minus 1. And if I know my output is 17, then I know that y is equal to 17. So I'm going to replace the y with a 17. So here I get 17 equals 2x minus 1. Okay, so then I would add 1 to both sides, so I get 18 equals 2x. Divide both sides by 2 and I get 9 equals x. Now I skipped the algebra piece here, like all the steps and stuff, because hopefully at this time you should be okay with it. If you need to rewind it just to give yourself a chance to kind of remember it, please go ahead and do so. Remember, you are in control of your learning right now. So let's take a look at what's written here on this next piece because this has some important information. So function notation can be very, very confusing because it really looks like multiplication due to the parentheses. So this right here is our function notation, okay? And it looks like f times x, but that's actually not what it means. So right here, but there's no multiplication involved. The notation serves two purposes. The first purpose is to tell us what the rule is, and the second purpose is to specify an output for a given input. And I'll explain to you what all that stuff means in a minute. So essentially, this is your function notation. And the way that we say this notation right here is we don't say f times x. Remember, it's not multiplication. We say f of x. And remember right here, what it's doing is it's telling us what the rule is. So right here, this f is telling us the rule, and then the x right here is the input. So this is saying you take an input x, you plug it into some type of a rule, some type of a function, and you end up getting an output, which is your y. Okay, that's what function notation is telling you. So, for example, right here, if you notice, our equation that we got up here was y equals 2x minus 1, okay? But instead, we can write our notation instead as f of x equals 2x minus 1. So what is this saying? It's saying, first of all, that y is the same thing as f of x. Okay, and it's also telling us that the rule is take your input of x, plug it into your rule, which is multiply by 2 and subtract 1, and you'll get your output, which is y. Okay, so if right here I want to figure out, well, what's my input when my, what's my output when my input is 2, then what I would do is f of 2. Because remember, 2 is your input. And how do I figure that out? Well, what I need to do is do the rule. And the rule says to take your x value, multiply it by 2, and then subtract 1. So I get 4 minus 1, which is 3. So that means that my input, when my input is 2, my output is 3. Okay, and that's essentially what function notation is telling you, okay? Now, one thing that I want you guys to be aware of is generally it's written as f of x. However, sometimes you can see it with different letters. So the reason why we use f of x normally for the most part is because f stands for function, so it's defining your function rule, and x is usually going to be your input. But for example, I could have r of z if I wanted to, and all this is saying is that z is your input and that r is the rule to find out what your corresponding output is going to be. Okay, so let's look back at example number 3 right here. Exercise number 3 says the deepest mine in the world, East Rand in South Africa, reaches 3,585 meters into Earth's crust. Another South African mine, Western Deep, is being deepened to 4,100 meters. Suppose the temperature at the top of the mine shaft is 11 degrees, so the top is 11 degrees, and that it increases at a rate of 0.015 degrees Celsius per minute as you descend. Represent the temperature in a mine shaft with a function, and then write it in function notation, okay? So first of all, we know that it's starting at a temperature of 11 degrees Celsius. So this is your initial value, which means that it could be probably maybe your b if this is a linear function. It is a linear function, and how do I know that? Because it increases at a rate of 0.015 degrees Celsius per minute. So this is your rate of change or your slope. So I know that my m is 0.015 and that my b is going to be equal to 11, okay? So how do I write this out? I know that my temperature is going to start at 11 and then it's going to increase by 0.015 meters or degrees per meter. Okay, so we'll say D for depth. So essentially we have T is temperature and that D is depth. Well, we know that T is your output right here. Okay, so I'm going to say right here that this is your output, and we know that D is your input. So this is my equation, this is my rule. My rule says to multiply the depth by 0.015 and then add 11 to it. However, how do I write this as a function? My output, which is T, is going to be based on my input, which is D. So T of D is going to be equal to 11 plus 0.015 D. Okay, and that is my equation in function notation. Okay, part B says use your function to determine the temperature at the bottom of East Rand and Western Deep mines. So we know that East Rand reaches 3,585 meters. So East Rand right here, we know it reaches this depth right here. So that's going to be your D value or your input. So how do I use my function rule? Well, if my function rule says T of D, this is saying put in whatever input you think you need to figure out. So my input is 3,585 meters. And then the rest of the equation right here says equals 11 plus 0.015 multiplied by my input of 3,585. Okay, so I end up getting 11 plus, and then you're going to multiply the 0.015 by 3,585, and you end up getting 53.775, and then you just add it together, and you end up getting 64.775. So that means that T of 3,585 is equal to 64.775 degrees Celsius. Now, what is this telling me right here? Pretty much it's just saying that when my input has a depth of 3,585, I end up getting a temperature of 64.775 degrees Celsius. Okay? All right, so the next thing that I want you to do is find the answer for Western Deep mines on your own and then compare with me to see how you did. Okay? So if we know that Western Deep has a depth of 4,100 meters, I'm going to use 4,100 as my input. I'm going to plug it in. Right here it goes in for the D in my equation. I do my multiplication, I do my addition, and this tells me that when my input is 4,100 meters, my output is 72.5 degrees Celsius. Okay? All right, on the next page, if you take a look right here at exercise number 4, it says for the function shown in the graph, determine each value. So let me just remind you that y is equal to f of x, but this time it's g of x, but it's essentially the same thing. And don't forget that y is your output, x is your input, and f is just your rule. Okay, so this is saying essentially if my input is 3 or if my x value is 3, what's my output in my graph? So I'm going to go to 3 on my graph right here, and I'm going to go up and I see that its corresponding y value is 2. So g of 3 is equal to 2. Okay, let's do the next one. I'm going to go to -1 on my graph because this -1 is my input. So I'm going to go to my x value, and its corresponding y value is 0, or its corresponding output is 0. So g of -1 is 0. Okay, now the next thing is I'm going to look at part C. It says find x if g of x equals 1. So this one's a little bit trickier. This one is telling you that your output is equal to 1 because it's y equals f of x. So your answer here is going to be your output. So this time I go to 1 for my outputs, and I see what is its corresponding x value, and its corresponding x value is 0. So here the answer is 0. Now let's confirm. If I put 0 in for my input right here, what output do I end up getting? I get 1, so it's exactly what I want. Okay. Now don't forget the domain is the set of all inputs, and that the range is the set of all outputs. So if I look at my graph right here, my inputs start at -1. I don't have any inputs to the left of -1. -1 all the way on, it keeps going to infinity. I have inputs everywhere on this graph because each one of these points has a corresponding output. Every single one has a corresponding output, but before -1, they don't. So that means that my inputs, my domain, is going to be every single type of real number, but it has to be bigger than or equal to -1. Okay, now let's take a look at our outputs. So our range, that's what our range is, or a set of outputs. Our range is going to be all the y values that are shown in my graph. So the lowest y value I have is 0 right here. And then it keeps going up, 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 up. Right here, since this has an arrow, it goes on to infinity. So my range is y is every real number, because it's every teeny tiny little number in between that is greater than 0. So what does this notation say? It says x can be any number at all, any real number at all, such that x is bigger than -1. That's what this line right here means. It means such that. And it just basically is defining what x values are going to work for us. So this is just saying all real numbers greater than or equal to -1. Okay? All right, exercise number 5, we're going to do some algebra here. So consider the functions f of x equals x squared minus 3x and g of x equals 1 minus 2x. Show that f of 2 is greater than g of 2 and explain what that means about their graphs right here. So if I were to look at this right here, to find f of 2, all I'd have to do is every time I see an x value, I'm going to replace it with 2. So this x is being squared. So I'm going to take 2 and I'm going to square it. And then it says minus 3 times x. I'm going to replace the x with a 2. Okay, so that means that f of 2 is equal to 4 minus 6, just evaluating it. So that means that f of 2 equals -2. So what this is saying is when I have this graph right here, when my input is 2, my output is -2. Okay, now I also want to do g of 2. So to do g of 2, all I'm going to do is every time I see an x value, I'm going to replace it with 2. So 1 minus 2 times 2. So I end up getting that g of 2 is equal to 1 minus 4, so g of 2 is equal to -3. So is f of 2 greater than g of 2? Well, we know that f of 2 is -2, and we know that g of 2 is -3, so -2 is greater than -3, and it works. So it is true that f of 2 is greater than g of 2. Now, what does this mean? That means that I can conclude that the graph of f of x is higher because it's greater than the graph of g of x when x equals 2. Okay, that's essentially all that it means. Okay, really quickly, I just want to show you graphically why that works, and then we will go on to parts B and C. So if you remember, f of x is x squared minus 3x. So I'm going to literally type that into Desmos. So f of x equals x squared minus 3x. So I can take a look at what my graph looks like right here. Okay, and then I'm going to look at what g of x is. G of x is 1 minus 2x. So I'm going to write in here g of x equals 1 minus 2x. And when I look at my two graphs and I go to 2, my input of 2, I can see that my f of x graph is higher than my g of x graph at that specific input value. Okay, so next thing I'm going to do is evaluate g of 3b. Okay, so how do I do that? I'm going to, every time I see an x value, replace it with 3b. This is still my input. It just happens to have an input that is a variable, but the idea still is the same. So g of 3b is going to be equal to 1 minus 2, and then instead of x, I'm going to replace it with 3b. Okay, so what do I do with that? I end up getting g of 3b is equal to 1 minus, and this ends up becoming 6b when I multiply 2 times 3b. Now I look at my expression right here and I ask myself, can I simplify this any more, any further? And I can't, so that's my answer. G of 3b is equal to just plain and simply 1 minus 6b. Okay, all right, now part C is a little bit trickier. So part C says to find f of x plus 2 minus g of x plus 2. So don't forget that f of x, we said, was x squared minus 3x, okay? And we also know that g of x is equal to 1 minus 2x. So what this is saying right here is that every time I see an x, I actually replace it with x plus 2. That's what it's saying. So to do that, I would say f of x plus 2 is equal to x plus 2, and then I'm going to square my input minus 3 times x plus 2. Okay? And then to do this piece right here, it's the exact same idea to find out g of x plus 2. So what this is saying is that my input is x plus 2 again. So every time I see an x, I'm going to replace it with my input of x plus 2. So how do I do that? This right here, it just ends up being 1 minus 2 times x plus 2, because my input is now x plus 2. So let's go ahead and evaluate this whole piece right here. So it says find f of x plus 2 minus g of x plus 2. Okay, so we know that this piece right here is f of x plus 2. So I'm going to say x plus 2 quantity squared minus 3 times x plus 2. And that's the whole first piece right here. Okay, and then I'm going to subtract what g of x was, which is 1 minus 2 times x plus 2. That's the expression that we got right here. And it's minus the entire thing. Now, I need to go ahead and do my multiplication. And here, to do x plus 2 quantity squared, I need to expand this out, or I need to FOIL it. So essentially what it's saying is just x plus 2 times x plus 2 minus 3 times x plus 2 minus, and then 1 minus 2 times x plus 2. So we'll go ahead and expand and do some distributing, and then we'll see what we end up getting. So right here, when I distribute this x right here to this x, I end up getting x squared. When I distribute this x to this 2, I get 2x. When I distribute this 2 to this x, I get 2x. And when I distribute the 2 to the 2, I end up getting 4. Okay? Then I'm going to distribute the negative 3 through, so I get negative 3x minus 6. So that's my whole entire first piece, the f of x plus 2. Then I'm going to distribute this negative 2 through, so I end up getting 1 minus, I just copy the 1 down, 2x, and then negative 2 times 2 is negative 4. Okay, and that piece right here is going to be the g of x plus 2 piece. So I'm going to simplify my first set of brackets. So I get x squared plus 4x right here. This gives me 4x. Take away 3x, I've got x. So it's just plain and simply x squared plus x. Okay, and then this 4 and this negative 6 get put together and they become minus 2. Okay, and then I'm going to subtract over here. I can put the 1 and the negative 4 together and I get negative 3, and I've got negative 2x in front. Next thing I'm going to do is I'm going to distribute my negative in between right here. So I end up getting x squared plus x minus 2 plus 2x, because this negative 2x becomes a positive, and then this becomes plus 3 because this negative 3 becomes a positive due to this negative in front right here. Last thing I'm going to do is put together my like terms, and then I'm all set to go. So nothing is like x squared. X plus 2x ends up being 3x, and then negative 2 plus 3 ends up being 1. And this is my final answer. Now, do not forget to distribute here. Please, I beg of you, do not tell me that x plus 2 squared is equal to x squared plus 4. That is incorrect. That will never be true. The answer is going to be x squared plus 4x plus 4. Okay, all right, and those are your notes. Make sure you took control of your learning when you did this, and you rewound if you needed to. You did your pausing if you needed to. Make sure you truly understand the concepts, so that way what we do in class is going to be a piece of cake for you. All right, have a great day.